So here we're going to give a bit of a review of how to simplify radicals. So I kind of think of radicals as the reverse of exponents. The idea being that if you have some expression where b to the n is equal to a, then we could say b is the nth root of a. What that would look like is b equals the nth root of a. So it does kind of switches the notation from an exponential form into a radical form. So it's another way of expressing it. So the idea being, we could say that 4 squared is equal to 16, but at the same time we could say 4 is the square root of 16. Or we could say negative 3 cubed is the same thing as negative 27, which would be the same thing as saying that negative 30 is equal to the cube root of negative 27. So what we can do is use this exponent form, this exponential form, in order to help simplify our radicals. So let's go through some examples here and refresh our memory of how to do this. So square root of 4, what I'm thinking in the back of my head is, what do I need to square in order to get 4 out? And here we're just simplifying expressions, so we're using the principal square root, which means we're using the positive number. Meaning, while I could have 2 squared equals 4, we could technically also have negative 2 squared equals 4. However, in simplifying, we just want one value coming out, so we just use the positive. So that's where principal comes through. This uses the principal. So we would just say that that is equal to 2. So in the process of this, we lose the radical symbol because we're getting that square root value in there. If you have negative on the outside, then the negative just stays outside. So what is happening when I take the square root is I'm just replacing this notation right here. So the square root of 36, so I'm thinking what squared would give me 36, and that would be the value of 6. So that negative would stay out front. If it helps, you could think of this as kind of 2 separate values, like a negative 1 times the square root of 36. And then you could see that would be a negative 1 times, and square root of 36 would be 6, so that would be negative 6. So sometimes separating that negative 1 away from it can help simplify. Square root of negative 49. Okay, so what I want to know is, what do I need to square in order to get negative 49? And when I'm squaring something, I'm multiplying the same thing to itself. So numerically, I know a 7 would work. 7 times 7 is 49, but either both of the values have to be positive or both have to be negative. If we multiply 2 positive values, that's going to give a positive. If I multiply 2 negative values, that's going to give a positive as well. So with that, there's no way that I can square a number and get a negative number out with the property that they will either both be positive or both be negative, and no matter which way it goes, the outcome would be positive. So that's one of the reasons why we can't take a square root of a negative number. It's true for any even roots. If we're a 4th root, 6th root, 8th root, if a negative number is underneath the radical, we can't do it. So with this, we could just write does not exist, DNE, does not exist, or undefined, or no real solution, which this isn't really a solution since we're simplifying, but no real number, not a real number is another phrasing you might see. All right. In this case, where we have a square root and a square, again, I'm asking, what do I need to square in order to get, in this case, 79 squared? And in asking that question, I've answered myself already. So what squared is 79 squared? Well, it's just that 79. So there's kind of this cancellation that occurs with the square root symbol and that exponent of 2 that would just leave us with what's underneath that exponent. There's actually, sorry, I'm going to come back to this because let's talk real quick about what if this was the square root of negative 79 squared. So, under that property that I just said, what I would do is say, that would be negative 79. However, what we just talked about was that we shouldn't be working with negative numbers here. Having a negative number as an outcome from our square root shouldn't happen. So if we have a property like this and there's a negative number inside, or even if there's a positive, what we technically do is use the absolute value symbol and say the solution would be 79. Because really, what we would do here is if we simplify it out, if we had that negative 79 squared and plug that into a calculator, we would get a positive number of 6,241. And then by that rule of using the principal square root here, we would end up with positive 79. So we shouldn't end up with a negative outcome here, even though by that property that we just talked about, those would cancel out. Technically, the rule goes of using the absolute value of what's under there, and this is a case of having even roots. With odd roots, it's its own thing, since we can have negative numbers with those. So just keep that in mind. If you see this, but it's a negative number, you actually want the positive number because of this simplifying and using the principal square root. Cube root of 27. So here what we're asking is, what do we need to cube in order to get 27 out? If you need calculator help with these, you can just start plugging in like what's 2 cubed, 3 cubed, 4 cubed. In this case, we'll see that we need a 3 right there. So that will be a positive 3. Cube root of negative 8. So here we're saying, what do we need to cube in order to get negative 8? Now, like I talked about up above, with the even roots, we ran into an issue. But notice with the cube root, and really odd roots in general, so I know that 2 times 2 times 2 is 8, and these all need to be the same number. If I made them all positive, then that would give me a positive number out. If I made them all negative, what would happen is negative times negative is positive. So positive times a negative, I can end up with a negative outcome here. So with that, when we take odd roots of negative numbers, we're going to be using a negative number. And similarly with that example we just saw, if the number's positive underneath the radical, you're going to have a positive value. So this is going to simplify to negative 2. So with odd roots, if it's negative underneath, negative outcome. If it's positive underneath, positive outcome. Alright, here we're taking the cube root of this negative 64 over 27. So, like I just said, if it's negative underneath, it's going to be negative out front here. And then I just need to think about what cubed would give me 64, and that would be 4. And what cubed would give us 27, and that would be the value of 3. So where this is coming from is by taking negative 4/3 and multiplying it to itself 3 times. And I'm just putting the negative in the numerator. It could have gone to the denominator. Really, in terms of symbol, negative times negative times negative will give us a negative value. And then when we multiply fractions, you're just multiplying the numerator to itself. So 4 times 4 times 4 over, and then you multiply denominators together, 3 times 3 times 3 of 27. So that's how the fraction works out, is really we can think about the numerator and denominator separately, just by how fraction multiplication works. fourth root of 16. So here we're thinking what to the fourth power would give us a 16, and that would be the value of 2. So I would simplify to 2. And our last one here. So as soon as I see a negative number, the first thing I do is check the root that we're taking. If this was an even root, I would immediately write does not exist. However, it's an odd number, so that means if what's underneath is negative, our outcome will be negative. And then taking the root of 1 will always produce a value of 1. So here, the idea of -1 to the 7th power, well, in terms of a symbol, the idea is that I'd have these pairings. In this case, across 6 of those, I'd have these pairings making positive numbers come out, but then I'd have this extra negative number coming out. So that's where the outcome is negative. And then, it doesn't matter how many times you do it, but 1 multiplying with itself always gives 1